Hello and welcome to the Grasshopper Parametric Design Series for industrial designers. As an industrial designer, you'll often need to construct seamless patterns across A-class surface models. Whatever the pattern, and we'll explore several types, it must flow naturally across complex surfaces without visible seams, even wrapping around if necessary. Unlike most tutorials that stop at single surface or mesh-based solutions, this series tackles the true industry challenge, building seamless patterns across complex B-reps with dozens of surfaces. This skill is rarely shared openly, but it defines professional proficiency in parametric design and solves real problems in automotive, consumer electronics, architecture, and beyond. Step by step, we will develop a universal workflow for seamless patterns on complex B-reps. To make it clear, we will start with hexagons, then extend the same method with some necessary modifications to diamonds, staggered bricks, sine waves, and more. Every example will demonstrate how the seamless approach works across multi-surface B-reps. And in the end, you will not only have fully developed scripts that work, but also understand how to design your own, which in my opinion is even more important. The series is designed for complete beginners. No prerequisites required. I'll explain all the nuances about NURBS, parameterization, math, so you can follow along easily. It's not rocket science and you don't need to be a programmer or engineer to grasp it. As for the tools, we need only one, Rhino. Grasshopper is not a standalone program. It comes built into Rhino by default. Both are developed by Robert McNeil and Associates and runs natively only in Rhino because they share the same computational cores, Rhino Common and OpenNURBS. While there are APIs that let you connect Grasshopper to other systems, such as Rhino Inside or Rhino Compute, those are just integrations. The native environment is Rhino itself. And while Rhino is not an A-class modeling tool, it's an extremely useful addition to your primary A-class system, whether that's Alias, ISOM, or NX. In industry practice, Rhino is almost always a secondary system used as a versatile multi-tool and parametric engine rather than a main modeling platform. So it's very useful to add it to your toolset anyway. We won't be modeling in Rhino directly, but I'll explain everything you need to know about how Rhino and Grasshopper work together. So even if you're never opened Rhino before, don't worry, just make sure you have Rhino 7 or 8 installed. And last but not least, if you follow this channel for Alias and A-class, don't worry, it's not going anywhere and we will keep grinding it. Okay, so as you're gonna see already in Rhino, mine has a dark theme. If you just installed it, it probably has a bright theme, but apart of that, they are the same. Mine was, I reset mine to default state, removed all the hotkeys, everything, so we will be in the same line. And before we run the Grasshopper, I will explain the operations with the viewports very, very quickly. So as you're going to see, we have 4 windows, and this is how it starts by default. If I want to activate one of the windows, for example, expand it on the whole screen, I will double click and I will double click on the title. For example, double click on perspective. Here you go, we have a perspective window expanded. Now if I'll double click again, I will go back to the 4 views. For example, there is a top view, double click, we get out. In the bottom left, we have these switches. Right now they're just changing the active window, but not expanding it. But if I'll double click and I will use them, you're going to see that it will change the type of the window which is expanded. So right now in the perspective window, let me quickly guide you through the operations. So everything goes through the right mouse button click. So right mouse button click and drag will rotate around the pivot. Shift right mouse button click will pan. Control right mouse button click will zoom. And there is a third mode, but for that we need geometry. So if I'll bring something like a box and I will hold Control Shift and hover, you're going to see that automatically highlighted me the part of the model, even a point, for example, as my new focal point. So for example, I would like to orbit around this point. So I'm hovering it, holding Control and Shift, and then right mouse button, and as you're going to see, it orients around this new point of interest. Okay. All right, now let me just select it and delete, and I will double click and go to the top view. So in the top view, the general controls are the same, but because we have less amount of freedom, it's an orthogonal view, so it's a planar view, the controls shifted a little bit. So here, to pan, I'm using the right mouse button. So it was a rotation, now it is a pan. The shift right mouse button still pans. The right mouse button pans and shift right mouse button pans. So now it's a simplification. For zooming, control right mouse button click works as before, but on top of that, you're gonna use your scroll wheel and zooming in and out this way. Very convenient, I believe. So I will keep the top view for this video right now, and let me actually run the Grasshopper. So you can run Grasshopper two ways here. So first, in the standard tab, you're gonna go to this green icon. It's called Launch Grasshopper. You will click and it will launch. Alternatively, you're going to see we have a console here. And if you didn't change anything, because you're going to change the behavior of the Grasshopper, or sorry, Rhino for that, of course, but if you'll just type Grasses, and you're going to see that it's immediately get me a telesense with the proper command. If I click, it will run the Grasshopper. I will click Escape and click on this icon because it's a convenient way to start it, right? So let me click on it. We go through the preloader and bam, we have ourselves a Grasshopper. Now note that it has a priority on focus, so it sits above the Rhino. That's intentional. This is the way how you're supposed to operate with that. You're gonna go in, just click and drag it to like another monitor, for example. This is your preferred method, but I prefer to keep it just on top because I don't like to turn my head constantly left and right, and we need the viewport with our Rhino. Not really that much for these additional controls. We'll talk about them later. But when you are already operating with the Rhino, the only thing you need is a viewport. Okay. Now let's look at Rhino itself and talk a little bit about its anatomy. Just what you see. So at the top, you have the service menu. Underneath, you have a palette. This is the default palette with all your nodes. This is a node-based system. You're gonna use in the main canvas. So everything here is a canvas. You're gonna use the same controls and it's as in the top view in Rhino. So right mouse button click drag, scroll wheel zoom, control right mouse button zoom as well. So the same, absolutely the same controls as here. Right, you're gonna see that this frame with a shadow, well, it's just a guide. You can place your nodes whatever you want. You're gonna start here if you want. We're gonna start here or there, doesn't really matter. Okay, now, so I want that we will be, for the duration of this course, the whole course, on the same line. And for that, I will ask you to change some basic setup for the Grasshopper. For that, we need to go to the display, and you must be sure that all three elements, draw icons, draw fancy wires, and draw full names are checked. Seasoned users of the Grasshopper uncheck them because that makes your nodes much more compact. That makes a lot of sense. But when you're starting, you're learning, it's actually much more convenient when you have the names and the wires, which represents the type of data, as well as the big icons as well. This is very important. So I ask you to turn them all on. Next, we go to the File, Preferences, and under the Widgets tab, scroll down and make sure that your profiler is checked. Show Profiler Widget. It will tell us how much time Grasshopper's compiler takes to compile the node. That's really important for us to debug, the choke points, and this will be pretty handy later. Okay. Now let's let me reiterate the task. Our goal is to create a seamless hexagonal pattern across multiple surfaces. The first step is constructing a planar, isotropic, orthogonal grid of points. This grid will serve as a foundation for our script. But before we can build anything meaningful, we need to start with fundamentals. Data management. Data management describes how a system, a programming language, or a parametric tool like Grasshopper operates on data, how it stores it, combines it, transforms it, and distributes it. Without understanding these core principles, there is no point in proceeding. You simply won't be able to use the system effectively. And throughout the course, we will explore the intricacies of data management, but today we begin with 4 basic yet extremely important operations. These are the pillars of data management. First, data input. Second, data merging. Third, data grafting. And fourth, data matching. All of these principles are required to construct the grid. So let's go through them one by one and then build the grid using our newly acquired knowledge. So, data input. The simplest way of data the type of data you can input in Grasshopper is a number. And actually, this is exactly what we need, because to construct the grid of points, we need numbers. The easiest way, and I will be saying it again and again and again, in Grasshopper there are multiple ways to do the same operation, and you have multiple ways to input numbers. But the most convenient one, especially for beginner, is using the node called number slider. It locates under the main palette, under the params tab, in the input category right there. Here it is. It's called number slider. So I'll click on it and then click on the canvas. Right, let me zoom in. I'm using the scroll wheel, and you're going to see that this is indeed a slider because it has a range and a number. So if I'll click and drag, you're going to see it goes from 0 to 1. Of course, we can change the range and use different numbers, but that's all for the future. So let me leave it at 0.25 for now and describe the method of data input and the actual sneak peek into the data management. So we brought the number in, but we don't know yet how it represents in Grasshopper in its data structure. But we easily can figure out and analyze that by using the very specific node which is designed specifically for that. This node called panel. And this node is so prominent, in fact, that it's just right under the slider. It even has its quick call out through the search panel, a hotkey, if you will, but we will talk about that in the next lesson. So today, not about hotkeys, today about the structure and the grid. So I'll click on it. and place it in the canvas as well. So now we have two entities here, two nodes. This is the node number 1, number slider, and notice that it doesn't have any inputs. This is the output, but the panel has input and output, which is very important, meaning that you can't connect anything to the number slider, but you can connect number slider to something else. And try it. Now we're connecting it to this node called panel to figure out what's inside, how Grasshopper represents this number in its data structure. So if I will click on the output and bring it, I'm just holding left mouse button and I'm bringing it to the panel, you're going to see that something interesting happened. So if you look closer, you're going to see that this 0.25 is actually our number. And if I will change that, you're going to see it will change. But a part of the number, there is two extremely important components. First sits in this darker row a number with curly brackets. This number called branch path. But to simplify things as a metaphor, I will call it a name for this video. In the next video, I will be calling it the proper way. I will be calling it the branch path. It just so it will be simpler for you to understand what it does. Underneath, we have our number. So this number sits within this container with a branch name. And the number to the left is the indice of an element. So this indice represents an order because there can be not one value, but multiple values. We'll talk about that in a second. And this number will represent its order in this group. So as I said, this one is a branch path. And for now, for us today, it is a branch name. This one, our value called list item, and the number next to it, 0, called indice. Now, the developers of the Grasshopper came up with a great metaphor for this data structure. They called it data trees. And it's a beautiful metaphor because it really represents the tree, if you think about it. Let me visualize this tree. So once again, it is a metaphor. So imagine that you have a tree trunk, right? Like some kind of a ugly, ugly tree here. Now, a tree trunk is a pure metaphor. It's not visualized, but you're gonna think about any data you brought in as something which has a tree trunk. A part of the tree trunk, we have this branch name, meaning that there is a branch. Let's draw a branch with a name of 0. Okay. And this is a list item. But if we once again think about that metaphorically, it can be represented as a leaf sitting on a branch. So imagine that this is a leaf. It has an indice 0. This is the first leaf on this branch and the last leaf because we don't have anything else. And its number is 0.25. And as a whole, as a structure, this called data tree. So this number represents in a Grasshopper as a data tree with a tree trunk, a branch with a name, and a value within it with its indice. Indice is 0. Why indice is 0? Why not 1? In Grasshopper and in any programming language, calculation starts from 0. So it's not 1, 2, 3, 4, 5. It's 0, 1, 2, 3, 4, right? 0 is not nothingness. 0 is a number. And in Grasshopper, and as I said, in other programming languages and other parametric systems, 0 is a thing. Everything starts from 0. And because this is the first element, it is a 0 element. All right. Now let me bring another value. Let's say another number. So you know what to do. Click and place. Now we have another number. Now this number is 0.25. let's analyze what's inside. You probably already guessed, but if I will click and drag, you're going to see that I have this same data tree. So now we have two trees, the first tree and the second tree. If I will change the number in this tree, the list item or the value of this leaf will change, but the structure of the data tree is not. And this is very important. Look at this. We have two different trees, data trees, with the different values in it, but the name of a branch is the same. You're gonna think about that. Like, let me bring my own metaphor. Imagine that this is a name, right? That's why I called them a name temporarily. Like, my name is Alex. How many Alexes are on this planet? Well, a lot, right? Maybe 100 million, maybe 200 million. I don't know. It's just a very popular name, right? But how many Alexes are sitting in the comfort of their home, capturing a YouTube video in a specific time, at a specific address, in a specific country, city, street, and blah, blah, blah? Well, only one. Me. I'm a very specific Alex. What does it mean? It means that the name of a branch local to its own tree. So trees are different, but the name of a branch is the same. And this is absolutely legit. What is a result of that is that it is impossible that in one tree there will be a branch, two identical branches. For example, the first branch will be 0, and then the next branch, and we'll talk about that in a second, because yes, we can do multiple branches, can be 0, and the next one can be 0. It is impossible. For example, imagine that I invited a buddy to my home, so capture the video together, right? And his name is Alex also. But how you dissect me from my buddy? Well, from perspective of the grasshopper, it basically says no. Two Alexes is not good. So the first one, who came first, will be Alex 0, and the next one will be Alex 1. And this is really important for the future, but just something I will ask you to remember. So this is basically how the data stores, the simple data, this is called the simple data or the atomic data represents. Now let's talk quickly about the next main operation, data management operation. And this data management operation is data merging. So of course, we're gonna still use these elements separately, or we can combine them together in a one bigger tree. So right now, let me just quickly illustrate. So we have another tree with another, tree branch with the same one leaf, but with a different value. So this one's 0.3, like, let's say 8. I will just round the number, right? So what I'm going to do is I can combine them together. Now, to do that, once again, multiple ways of doing that in the Grasshopper, but I believe the most rookie-friendly is to use a dedicated node. This dedicated node locates under the Sets tab, under the Tree subcategory here. Now, by the way, we will go by, just because our task is pretty complex, we actually go for almost all of the nodes in all of the sections, and of course all of the nodes which describes the data management, because in the sets, everything here is one way or another operates with the data, operates with data trees. So we need the node called merge. It's right there. So click on it and place it. Okay. So now we have a node which has two inputs by default and an output. If I will take the first number, click and drag into the data 1 and release, and then click on the second one and drag and release, something interesting happens. We don't know what, because we need to analyze it using our panel, but the node itself already is quite interesting. So you see, when I add the second one, the third element automatically pop up, or the input for the third element. That's for your convenience, but that means that if you zoom in whoa, something interesting happened. This node, one of many, not all of nodes in Grasshopper has this, but this one and others, and a lot of others as well, has this capability. You can add more inputs as well as you're going to remove them. So these nodes give you an ability to add together as many separate values as you want. Okay, so we use this one, our first data tree, and the second value in the second data tree, and merge them together. Let's analyze what's inside. You already know what to do. In the parameters, this node called panel, click and drag, and then connect. Okay. Well, if you look right now, you're going to notice that something really interesting happened. We have two separate trees. Every single one of them sits within its own branch. And now they are merged together under the same name. So you're going to see this name of a branch was 0. And this name of the branch was 0. There is the first. The first one in the list is a 0. And because they are identical, the merge command knows this because you plug them in, and it merges the values together under the one branch, meaning that now we have a tree with a name, with a branch of a name of 0 with 2 list items. So this is why it is a list. You're gonna see now it is a list, and these indices represents the order, the first one and the second one. So this is the first one, this is the second one, and this is the numbers 0.2 and 0.38. Okay, so now they're sitting together, and that's what merging does. It can be a little bit more complex than that, but this is the basics. Important to note that if these trees has different names of the branches, they will not merge. Instead, they will stack. But to understand this concept, we need to understand the third one first, the third main one, and this is data grafting. So we already know how to bring data in, that it represents as a data tree with a tree branch, a list item, and its indices, and we're gonna merge them. Now let's look at the grafting. For the grafting, we need to use a very specific node which called graft, and it locates under the sets in the tree category. It's a very prominent node, one of the staples. All of them are the staples, but this one, I believe, the most important one, called the graft. So I click on this and bring it in. It looks like this kind of small, I don't know, tree, right? And as you can see, by default, it's orange. Why it's orange? It means that there is a warning message. Red is an error, orange is a warning message. So if I click on this icon, it will tell me what's wrong. Input parameter tree failed to collect data. Why? Because we didn't plug anything. So I have here this tree with 2 elements inside. So one branch with a name of 0 with 2 elements inside. So what the graft does, it atomizes the data the way that there will be always one leaf per branch. So if you have 2 leaves, every single one of them become to be independent, sitting on its own branch. Let me plug it in and analyze. So once again, we go to the panel and connect. Right. So what's the difference? So as you're going to see now, they were in the same branch, and now they're different. If it will be 3 elements or 4 elements or 10 elements, the grafting operation always atomizes data. It always restructure the data structure the way that there will be only one list item per branch, and there is not enough branches, it will create it automatically. So now every single one of them sitting on its own branch, and this is the only thing which grafting does. If there will be, let's say, 100 elements within the one branch, it will become to be 100 branches with one element inside. It can't be two. Grafting always atomize the data. So it can be visualized like this. We have a new data tree with two branches. And if you noticed, and I believe you did, the name changed. 0, 0 and 0, 1. And two leaves. So this is a leaf with indices 0. This is the leaf with the indices 0 as well, because this is only one element. And their correspondent values, 0.25 and 0.37. Okay. Now in vacuum, it's not really important, but at the end of the day, it is the same data, but the data structure changes. And this is extremely important for us in the future because we need to construct a grid. And without grafting, it will be impossible to do properly. All right. Now let's talk about the names. You're going to see that the name become to be more complex. And if you remember that just a minute ago, I give you an example with me and my buddy sitting and capturing this video, and we are both Alexes. And from the perspective of the grasshopper, it's a big no-no. We're supposed to be different. And that's what the grasshopper did. So there was only one name, Alex. But when there are two different branches, the first one will become Alex. Like imagine this is Alex. Alex 0. And the next one, Alex 1. And the next one, Alex 2. 0, 0, 0, 1, 0, 2, 0, 3, and so on and so forth. Right now we have only two elements. So as I said, it is impossible that they all will have the same branch name in a one data tree. They always will be separate, and Grasshopper will do its internal data manipulation so that it will never be identical. And that's how it grows the name. Now the name is longer and it consists with two numbers. All right. Now, the grafting itself is a part of the equation. The grafting has its sibling. It's called flattening. The flattening is a reverse separation. It does completely opposite. So if we have a grafted tree and we go into the sets tree and then flatten tree, this one, it actually reverts everything back. It collapses everything under the one tree branch. And if I'll plug that here, you're going to see that we go back where we started. Right. So both of them are actually is a part of grafting, but this is the actual grafting and this is the reverse separation. In the future lessons, we'll be using both of them heavily for very specific purposes. I understand that right now it's just a mumbo jumbo, like what's the point of all of these operations? But trust me, just in a few minutes you will understand why it was so important. Okay, so before we move on to data matching, I would like to combine the data grafting with data merging. We already used the concept of merging on two separate data trees, and you're going to see that we already have a list. Now, this version, let me delete. In this version, we have a grafted tree. And let me just clear things here. Let me just now try to merge this data tree with two elements within the branch, with this new data tree with two branches and one of elements within. So if I will try to do that, so let me go into the tree merge connect. And by the way, the order at which you plug them here matters. So because the D1 was 0.25 was first, 0.375 was second, and the order matters. At least in this situation. There are situations where it's not, but a story for a little bit later. So if I will plug this data 0.25 and 0.35 into the data one, and I basically tossed the whole data tree, not just number, but all the construction is right there. And I will use the our grafted version of it. what do you think will happen? Well, actually, let me quickly show you what will happen. So if you look closer, you will notice that, and as I said before, if the data, let me just bring the panel again. If the branch names are not the same, they will not merge, they will stack. And that's exactly what happened. You see, the first one stays intact, 0.25, 0.37, because it has the branch with the name 0. This tree doesn't have the branches 0, it has 0, 0, 0, 1, they're different. And then they go next. They just stacked in a one big tree. And now we have, because they're not identical, they are separate now. This is the branch 0, then a branch 0, 0, and a branch 0, 1. This one has 2 leaves, this one 1, and this one 1. This is our new data tree. So this is a stack. Very important operation, which we'll use, of course, and capitalize on that. But for now, we just need to understand why they are not all merged in a one big chunk. On top of that, I also want to mention, I said that in general, order matters. So here, order matters. But in this situation, order doesn't matter. Why? Because these data the tree branch names are longer than this one. And the shortest comes first. So if I will change the order and plug this here and this here, let me actually do it. To do it, I'll just click and drag. It will automatically replace the inputs. You're going to see that it doesn't change a thing. The 0 still first, right? No difference. Well, that's because it has a smaller name. So just keep it in mind for the future, and we'll talk about that as well a lot. So this is the concepts of data input, data merging, data grafting. The next important pillar of data handling is data matching. Without data matching, so we have almost everything in terms of the operations to construct a grid, except last one, and this one is data matching. Data matching represents through few different nodes and different mathematical operations, but I would like to introduce you to data matching through the very specific one. It sits under the sets, under the list group. So here, I will go for all of them, of course, but if you here go to the bottom, you're going to see there are three very important nodes called cross-reference, shortest list, and longest list. I will use the longest list as a demonstrator for a lot of reasons. In this video, you will understand why, but just a little bit later. Now, it has two inputs and two outputs, list A and list B. Now, I want that I'm not a big fan of naming here because technically it doesn't really take a list. It takes the whole data tree. Like here, we plug the whole data tree. We plug the whole data tree. This is a data tree with a number in it, right? So when it goes to the list, it actually looks for the data tree. So it will be data tree A and data tree B. If I'll zoom in, you will notice that as with the node merge, it has additional capabilities. I can add more inputs. This is another node which has that. But on top of that, it has additional mode selector. There are quite a few nodes which has this, and this is the one of them. And the node by default, the mode by default says repeat last. If I will right click on the node, right click, you're going to see there is a couple more options. Repeat first, repeat last, the current one, interpolate, wrap, and flip. I will not go through them right now. We will focus on the repeat last as a default one. So to understand how it works, let me bring another set of numbers and set of strings. We already know how to bring numbers, so let me just do it again quickly. So we go into the parameter slider. Let's bring it another one, right? Let's go through the merge command. And by the way, guys, if you ever tried Grasshopper before, right, I would just have some basic operations, like why I'm doing it through these menu, we have a search command, we have these, yes, we have, and I will tell you how to operate properly and really effectively. But that's for the future. I don't want you to, I want you to focus on the data management here. That's why we do it in a clunky way. So I will click the merge, join them together, and we'll have already ourselves a list, right? Or basically a data tree with two elements, or two list items, or two leaves in one branch. So let me inspect quickly. Okay. So let me change this number for something else so that it will be different. And the next thing which I want to do is I would like to add strings. I didn't tell you how to add strings. And as always, multiple ways of doing that. But the simplest is to use panel. Yes, panel. The panel is not only used, and I mentioned that before, to analyze the data structure, but actually it gives you an ability to input data as well. Numbers, strings, which means letters, formulas, and a lot of other stuff. So let me click and place it. Now, as you can see here, it says double click to edit panel content. And if indeed I will double click, it gives me an ability to add something. And I will type A and click away. This is important. Why you need to click away, I'll explain a little bit later. So you click away. Now we have a panel A. Let's bring another one. Double click, select, and I will type B and click away. And this is another panel with B. Let's merge them together in another list. You already know how to do it. We go to the sets tree merge. Data 1, data 2. And let me quickly analyze this. We'll plug a panel, but this time here. And now we're gonna analyze what's inside. So we are ready to check how the data matching in the example of a list node, the longest list works. So you're gonna see that we have two values. Let me actually, you know what, let me actually do a little bit more. So I need another one. Let me go another one here, and let me go and bring another letter. Let's say C. Click away, not enter. Okay, plug it. All right, so if I will plug this data tree with 3 elements within the branch into the list A, and this tree with 3 elements in the in one branch in the list B, the output, well, the output will be surprising because it basically do nothing. And here is another one. Okay, so if you compare, you're gonna see that nothing changed, like it just bypassed and did nothing. It does the work, but you can't see it because it matches the data. And from the perspective of this matching data algorithm, they are matching. But what if one of the trees will be smaller than another one? So this one will be only 2 elements in a branch instead of a 3. Now to do it, I need to either delete the slider or just disconnect it. Let me tell you how to disconnect nodes. So if you hover on the input, hold Control, click and drag where it comes from and release, it will disconnect. Alternatively, you're gonna, let me just connect it again, you're gonna right click, disconnect number slider. Not very convenient way of doing it, especially in 2026, but Grasshopper is an old system. We will talk, by the way, why Grasshopper is an old system, where is Grasshopper 2, and so on and so forth, but later. So that's, yeah, you will get used to it, but there is no shortcuts, sorry. So this is the only way how you're gonna do it. So now as you're gonna see, we have 2 elements, and this one has 3 elements. And if you look at the outputs, oh, something interesting happened. So the list B, or the input for this node, the list B and list B in the input and output, absolutely identical. They didn't change. But the list A input, indeed, and output changes. It was 0.25, 0.37, now it is 0.25, 0.37, and 0.37. What happened? Now this node, it analyzes the structure of the trees and tries to match them by three parameters. First, amount of elements in the list. Second, amount of branches in the lists. And the third, the branch names. So all three goes into effect. So right now you're going to see that we have the two lists with only one branch in it. And indeed, both outputs are with the one branch. The longest list from two, because once again, this is called longest list. What is the longest list between this one and this one? This one, 3 elements. So this one stays untouched. It has one branch, and both of them has one branch. This is the longest one. It stays as it is. This one, on the other hand, has the same one branch, but it has only 2 elements inside, element 0 and element 1. It needs another one to match. And these additional component, this mode, it tells you how it's supposed to match it. And it says that I will match them by repeating the last element. What is the last element here? 0.37. So it takes 0.37 and repeats it so that now we have the same length of a lists for both trees. So if I will remove another one here, it will be 0.25. Let me 0.25, 0.25. Let me do it. Control, drag. You're going to see it just takes the last one, and what is first is the last as well, obviously, and it repeats it 3 times. Okay. So let me join it back. So now we have 2 elements in the list. What if instead of a repeat last will be repeat first? What it will take the first element and then repeats it. How much it's supposed to repeat? How many times? 1 time. So it will be 0.25, 0.25, 0.37. Let me show you. Right click, repeat first. 0.25, 0.25, 0.37. So this is the basic data matching. But what's more importantly is that we already know the concept of grafting. What happens if we take the concept of grafting into this construction? And trust me, very interesting thing happens, very interesting and extremely powerful. So I will go into the sets, tree, graft tree, and I will graft this data, basically how we did it before. So I'm just repeating the operation. You already know what will happen. And how do you think what will happen next if I will plug these into the list A? And if you look here, let's analyze before we do, because I believe it's really interesting to just think about that a little bit. So now we have 2 data trees which are completely different. This one has only 1 branch. This one has 2 branches. This one has 3 elements within the branch. These ones are only 1. What Grasshopper is supposed to do to match them? Let's look at the list B for now. So we have 2 branches, and remember, this is the longest list, 2 branches. So it will take the longest list. The longest list is ABC. But because there are 2 branches, it's supposed to be within 2 branches. So it takes the ABC with the branch 0 and then duplicates it and with another ABC with the branch 0. Once again, 2 branches, this is only 1. What we need to do? Bring another branch, another lists. So if I'll plug that, there will be ABC in 2 branches. What will happen with this one? In this one, the 2 branches already the maximum. This is the longest one. So it will stay with 2 branches. But the elements are not the same. Only 1 element per branch. We have 3. What it will do? Repeat. Right now it repeat first, repeat last. Actually will not do much in this case. It will be the same. It will repeat this number 2 additional times and this number 2 additional times. Now let's check. Oh, you look at that. So because we have 2 branches, now it just doubled. And because these the list B, or the data tree B, has 3 elements inside, it will repeat it 2 times, so there will be 3 elements. So now these data trees are matching. You see how much more data, this is what we came with, and this is what we're left with. We have much more data on the output, and these data are perfectly matching in terms of the paths, list lengths, and the amount of branches, right? That's what data matching does. And if you think about the practical usage of that, I will tell you that we actually already constructed ourselves a grid. The only thing is that just the wrong numbers. To understand why we actually solved already our task, we need to talk a little bit about the grids and the points. So, as I said, we need to construct a grid of points. To understand what it is, let's talk about the points first. Now, point is a description of a position. It basically a position in Cartesian coordinate system. And it describes by three numbers: x component, y component, and z component. I believe you know this really well from school, and this is something which is really prominent. And as we're talking about the Cartesian coordinate systems, we actually it's widespread. We're using it in science, in computer graphics, in programming. This is Cartesian coordinate system. Of course, you have axis x, axis y, and axis z. So this is how the point will be represented. And indeed, this is how points represents in Grasshopper as well. So Grasshopper represents the points through three values: component x, component y, and component z. Now, if you look closer, we are in the top view. And I mentioned from the beginning that we need to construct a planar isotropic orthogonal grid of points. We will talk about isotropic and orthogonal a little bit later, but planar means that it is planar, it doesn't have depth. So basically we constructed within the flat plane, and we are now in the top view, indeed in the flat plane. This plane is xy plane, meaning that for us, for all the points in this grid, z will be 0. Every point will has z 0, but x and y will change. Let's draw a set of points to understand the numbers, because to construct the point and as a result a grid of points, we need to give three sets of values: values for x, values for y, and the values for z, which will be 0. So let me just visualize this. So imagine that this is our y and this is our x and y, like this. So imagine that we have a grid. So we have a point here, right? Let's do another one here and another one here. So 3 points, and then another one, so that it looks like a grid, right? Just another one, and let's do one more. Let's see, here, and here. So all of the points has 3 components: x, y, and z. Z is always 0. So let's look at the x component for the first point. What is the value for x if this is the 0 and this is some x, like x plus and y plus? What will be the component for x here for this point? 0. It's 0 component. What is the next one? Once again, x. Let's say that we want to have some specific step, right, between the points. Let's say it will be 20, right? So the next one will be what? 20. What will be the next one? 0, then 20, then mass addition operation. We will talk about that a little bit later, but it means that we have the same interval: 0 plus 20, 20 plus 20, 40, 40 plus 20, and so on and so forth. So the next one will be 40. The next one will be 60, and the next one will be 80, and then 100, and so on and so forth. What about this row? What will be the x for this? Well, the same, 0. So about this one? 20. What about this one? 40. How about this row? Same, x 0, x 20, and x 40. Okay, I believe that's pretty convenient. What's about the y? Let's look about the y component now. Now y for this one will be 0. Y for this one, 0. For this one, 0 as well. It's on the x. The y is 0 for all of them. What's about this one? Once again, let's say that the spacing will be 20. So this one, 0 plus 20, well, it will be 20. What's about this one? 20. This one? 20. What's about this row? 0 plus 20, 20 plus 20, 40. 40. 40. 40. Well, doesn't ring a bell. 0, 20, 40. 0, 20, 40. 0, 20, 40. 0, 20, 40, 0, 20, 40, and etc. etc. How about the y? 0, 0, 0, 20, 20, 20, 40, 40, 40. Let's look at our grid. You're going to see that we have two sets which are merging together. Just kind of bring them down a little bit here. Let's look at these numbers. They repeat the same number 3 times, and then the different number 3 times, and then another different set of numbers 3 times. 0, 0, 0, 20, 20, 20, 40, 40, 40. Same numbers. Then the next set of numbers. Then next, this is y component. What's about this one? ABC, ABC. 0, 20, 40. They are different within the branch. Then 0, 20, 40. In the next branch, they are the same. Then 0, 20, 40. Again, the same numbers. This is our X component. We actually already constructed the grid. It's not parametric yet, but we will do it right now. So let me now delete this and delete this. So first of all, we need to give ourselves very specific numbers. Remember, the step I decided, it can be anything. I decided it'll be 20. So 0, then 20, then 40, so on and so forth. Mass addition operation for X direction and for Y direction. So I need a set of numbers to construct the set of points. And you may imagine, I believe, that if I will use this approach where I manually bring every single value, for example, 0, 20, 40, 60, 80, and then try to construct grid this way, I can do that, but imagine that I want to change the amount of numbers. What if by default I need 10,000 by 10,000 grid, 20,000 by 20,000, 100,000 by 100,000? Well, good luck, bringing all of this data manually, right? So we need an automation. Can we construct in Grasshopper a series of numbers with a defined step of 20? And the answer is yes, of course. This is a very specific node here. Actually, two of them, one called the range, another one called series. And in the next video, we will talk about the range. In this one, we will talk about the series. So I'll click on the series node, which allocates under the sets, under the sequence command. Here it is. And bring it in. Now, first of all, you probably noticed that this node has a different color. It has a different color because it can't be visualized. It just represents the numbers. It has a little bit more additional things to that, but you shouldn't really worry about that now. So just don't worry. It just can't be visualized here. All right. And you're going to see we still didn't visualize, well, anything yet, but we will very soon. So this node gives us a series of numbers with start, step, and count inputs. And indeed, if I will hover on the start, you will see that the actual values are already plugged in. A lot of nodes in Grasshopper has default values. Not all of them, but this one is the one of the nodes which has them. So you hover, you're going to see one locally defined value, 0. So the start is 0, the step is 1. So this is the mass addition between the values will be the step of 1. So, and the count is 10, meaning it gives me the set of numbers 0, then through the step of 1 will be 1. Once again, come on. 1, then 2, then 3, then 4. How many of them will be total? 10, meaning that it will start from 0 and end with 9. Let me visualize it. So I'll go to the tree. Oh, sorry, what I'm doing. Into the panel and plug it in, and you're going to see that we have a list of numbers 0, 1, 2, 3, and then 9. Why 9? we start with 0. Remember, everything starts with 0. And one important note here, you see that the indices of the list in this tree are basically one-to-one to the actual values. Well, this is a coincidence. If I will change the step, they will not. Indeed, if I will just bring some different value, for example, I want to bring the value 20. And let me actually do it for the panel this time. So I click on the panel, double click, type 20 and click away. I will talk about click aways at the end of this video. So, and plug that into the step, you're going to see that now it's a different set of values, right? All right. So now we have 0, 20, 40, 60. This is a range of numbers. Really nice. Now, let's say that we want to control that so that I'm going to manually change the parameter. And right now I need to go in, select, change, hit enter, and then it will change. So I need a slider for that. But if you remember, the slider limited between the number 0 and number 1. And on top of that, it has float values. So it's not an integer. Well, that's not great. I want to have, for example, a value 6. How am I going to do that? Or maybe value 20. How am I going to do that? I will double click on it. And you're going to see there is a couple additional options for me. Now, first of all, rounding, I will click on this n number, the n value, which stands for integers right now. And then the mix and min and max range I will change. So let's say the max will be 20. I can just double click, type 20 and click on the green accept button or enter and hit OK. So now when I'm moving that, you're going to see that it goes from 0 to 20. Let me go this step back to 20. So I just click and drag and replacing the previous node. All right. Now we have 0, 20, 40, 60. Now we don't really need that many points for our test. So let's change the count. Let's say 4 is enough. So a 2, I can of course kind of bring it again and change all the values, or I can just select the node, Control C, Control V, and I duplicated that and plug that into the count and change the number to 4. So 4 points from 0, 20, 40, 60, and their order, their indices will be 0, 1, 2, 3, okay, in the tree. Before we move on, I would like to mention one important thing. Remember when we did grafting here, we have a list with the name of the branch name of 0. And when we graft that, it becomes to be more complex. But if you look at this node, you're going to see that it's complex already. We didn't graft anything. It's just a single list. Why? It complex. Why it's not 0? Why it's 0, 0? Well, this is something which a lot of people critique in the Grasshopper in all its kind of like 12, 13 years span, because it's not always convenient. Now you see, this node is not only giving a series of numbers. From the perspective of the Grasshopper, it changes the numbers, it modifies the data structure by default. So if I will, for example, analyze only the number and plug that in, it will be 0. But the moment we, let me just actually completely disconnect them. Control click, check it by default, and it's already 0, 0. So it treats it like this. You actually plug the default value here, means that you already plugged something. So the actual value was 0, 1, and 10. As it, like, you take this number with this data tree and already plug that into the correspondent input, and then it does operation and grows you additional numbers, and this treated like additional operation through the data management and represents the history. So this additional complexity of the names, it's not only a necessity because you can't have the same branch here inside with my metaphor with 2 Alexes in one room, like Alex 0 and Alex 1, but it serves a different purpose on top of that. Look, 2 purposes. This is the first one, or the result of that. And the second is that it shows you the history of modification of your data structure. Why it was critiqued? It was critiqued because it's not always convenient which element, which node actually perform this operation, because some of the nodes not doing that. And some of them do. Like why the series does this, I already explained, because it changes the data structure. But some of the nodes which we'll go and describe in the next lessons, they're not that obvious, and they still can bring you additional data structure. And this is very important down the line when we need to match the data and where we need to match it manually, not through these components. But that's a story for another day. All right, so I deviate a little bit from our task. So let me bring start 0, step 20, count 4. And you're going to see that right now I already changed the connection here. I can hold Control and click drag to disassemble that, or I can hold Control Shift, click and drag, and change the current link to some other input like this. Once again, Control Shift, and I switch that. Not delete it, but just switch. Okay, and the count will be to 4. Okay, so we have ourselves a series of numbers, 0, 20, 40, 60. We automated the process. Now we need, do we need another one? No, why? Because 0, 20, 40, 60 will be true for component X, and the same numbers will be true for component Y, just in the different arrangement. In which one? We already know in which one. Through the list matching, we're going to construct that. So let's do it. I will go into the sets, list, longest list, plug that in, and then I will do the same operation. I will graft this list, so I'll go to tree, graft tree, plug that in. You're already familiar. See how it's even more complex, because this one was 0, this one 0, 0, this one was 0, 0, now it is 0, 0, 0. It can be much longer than that, trust me. That's why we have the node called simplify and additional modifications and nodes to operate with these names, or the paths, but we will talk about that in the next videos. So it's a grafted structure. This one, original one, is not. We already know what to do. We need basically match the data between the original list and this list to construct the repeated pairs. So if I plug this in list B and this one is in list A, and by the way, it doesn't mean that list A is a driver and list B is following, as you, I believe, already understand. They work independently from each other. It matches everything to everything. And if I will look at the list A, because we grafted the list, now the list B, let me reiterate on this once again. As the list B has 4 elements in the list and we grafted it, now I need to have 3 additional zeros, 3 additional 20s, 3 additional 40s, and 3 additional 60s to match the data. And this is exactly what we have. 0, 0, 0, 0, 20, 20, 20, 20, 40, 40, 40, 40. This is our Y, obviously. And then this one is now 0, 20, 40, 60, and then again and again and again, because we have a lot of branches. Now we match the branches, so they are identical, pretty much the result of this operation, which I already described before, right? Perfectly matching. Now to move on, let me quickly adjust some things. So in the list, I will right click, select and type Y and hit enter. So now it is an Y component. And this one will be the X component, like this. So it will be easier for us to understand what is what. So this is the Y and this is the X. So we have the numbers for our point. Once again, X, Y, Z, right? So we have X, we have Y, the Z is always 0, but that means so we're supposed to have as many zeros as the values for X and the values for Y and the values for X. How can we do that? We need all 3, right? So that we're going to construct all the points. So we need this list with 4 branches with 4 elements inside, and all of them supposed to be zeros. Let's look at our output of the series once again. Now by default it was 0, 20, 40, 60. How convert all of them to zeros? Well, I believe it's quite obvious. Let's multiply them by 0. So we go to the math operations. In the operations here, this one called multiplication, I believe it's quite obvious. has two inputs, and as you can see, I'm zooming in. This is another node where you bring much more than just two, and you plug your series, and it will take all of these values inside, and then you need a number. Let's bring this number through the panel. So I will go parameters here, bring it in, double click, type 0, click away. I still remember that I need to tell you about this, don't worry. So in the 0, and let's look at the output. Click and drag. All of them are 0. So basically this node, as many others, what it does, it takes the values one by one. It doesn't matter for this node how many branches you have, how many elements inside, doesn't matter. It takes the first one, multiplies, next one multiplies, next one multiplies, until it goes through the whole data tree and give you the results, zeros. What next we're supposed to do? Remember, we have 4 zeros. How many zeros we really need? That many zeros. And we need to be, so they will be in the corresponding branches. How are we gonna do that? Very simply, we zoom in, click, and plug. That's it. Because it still has 4 elements, pretty much as the original list, right? It will behave the same way as the component X. 0, 20, 40, 60, 0, 20, 40, 60, but because they are all zeros, it will repeat them 0, 0, 0, 0, 0, 0, 0, 0, and so on and so forth. So matching these two, right? Let's check it out. Yeah, here we go. Okay, let me right click and say that this is Z, enter. Okay. Okay, so we're getting somewhere. Now we have 3 components, X, Y, and Z. Next, we need to construct a point. To construct a point, we go to the tab called vector. If you remember math, you're not surprised that points are in the vector tab. If you do, don't worry, we will talk about that later. So the actual node is here, it's called construct point. I'll click on it and plug it in. One important thing happened. You're gonna see we actually have something in the viewport. If I will click on it, you're gonna see it become to be green. We have a point. Why we have a point? Because X, Y, Z coordinates, as well as the series, for example, has a default parameters or default values. Let's put it this way. So if I will hover on X, it will tell you 0, Y, 0, Z, 0. Fantastic. So it has a point with all 3 values already set in 0, 0, 0. That's why it is in the beginning of coordinate system. Okay, let me quickly analyze how it represents in the data structure, right? So go to the sets, parameters, the panel, click and drag, and this is how it represents. So this point represents as a data tree with 1 branch, 1 element in the list, pretty convenient, and with these values in curly brackets. This is the point. This is how Grasshopper represents points. 0, 0, 0. This is X, this is Y, this is Z. And by the way, the visual representation and the data structure representation for vectors is the same. Y we will talk about a little bit later, but this is our components X, Y, and Z. Okay, so if I will plug the X component to the X, the Y component to the Y, and Z component to the Z, because they are perfectly matching between each other, it will go in and will take the first branch element. This will be X, and then correspondent Y, and then correspondent V, and then X, Y, Z, X, Y, Z, X, Y, Z, then the next branch 20, 0, 0, 20, 20, 0, 20, 40, 0, and so on and so forth. Because they have the same structure, the same names, and the same length, it will take it one after another. So it just kind of already used the matching lists. So everything has its own correspondent values. So let's do that. X to X, Y to Y, and Z to Z. Look at that. We have ourselves planar, isotropic, orthogonal grid of points. Let me quickly explain what is isotropic and orthogonal in the context of the grid. Now, isotropic in the context of the grid, because it has a few different meanings in mathematics. It means that the distance between the points in in rows and columns is identical. So from this to this is 20, from this to this is 20, this to this is 20, this to this is 20 also. Another important property is that the amount of points on x direction in y direction are equal, and indeed they are. This is a 4 by 4 grid. So basically the aspect ratio is 1 to 1, and both of these two requirements are met, meaning that this grid indeed isotropic. What does orthogonal mean? It means that the rows and the columns are perpendicular to each other, 90 degrees or half a pi, right? Okay, I believe this is pretty convenient. So when we already constructed the grid, and it's actually parametric, we can drive this grid by changing the step or the count. Oh, very convenient. Very convenient stuff. Well, let's bring it back in, like how much was 4, right? And we are not done yet, because there is something interesting here with this point node, but I don't know, will you be able to spot it? You probably didn't, so let me quickly explain. So I will delete this point for now and just bring it again. So I'll go to the vector point and bring it in. Now imagine that we already have our series here, the series of numbers, for example 0, 20, 40, 60. How do you think what will happen if I will take these numbers, but instead of doing the matching and grafting to create the pairs, just give these 4 numbers to the x coordinate? Well, if you think logically, what's supposed to happen is that we will be able either to construct one point and get a lot of errors on the other ones, or it will not work at all. Why? Because we have x0, x20, x40, x60, but y, one locally defined value, only 1 0, and z, only 1 0. So we have only one pair, 0, 0, 0, 20, no data, 40, no data, and so on and so forth. So what's your prediction? Will it be a 1 point and errors, or just an error at all and no points? Well, if I'll click and drag, it's neither of those. All the points were constructed. But how? You see 0, 20, 40, 60, we have this. We have 0 and 0 for y and z for the first row. But how he actually able to add these additional zeros here? Just to take it just 0 and you just replicate it a few times. Z here, zeros as well, replicates it a few times. It actually constructed me, a grid, no, not a grid, but a row of points. Well, the answer is, there is no magic. The answer is that this node, longest list, or better say its functionality in terms of the longest list data matching, already here in this node, its functionality baked inside. That's why I use this one as an example of data matching, because the data matching, the longest list data matching, is powerful enough so that it actually built in quite a few nodes already in Grasshopper, and the construct point is not the only one. We'll talk about a few others in the future, meaning that we actually don't need all of that. So when I did this, it was a buttered butter. So I did matching, and then it did matching again. So basically this is useless. If I will just remove that, leaving only the grafting for the matching component inside of the construct point, it will give me the same result. Let me show you. Let me just delete this one. Let's delete this one. Just clear the node setup a little bit, right? So this was our original. Now what we're gonna do is we go in to the vector construct point. Now, if I will plug this data on X and the same data on Y, I will give myself what? A diagonal line and not a grid. Why? Because it goes through the matching, but the data here is identical. It is 0, 20, 40, 60, 2 times. What to match? Oh, it matched it. They are matching already. 0, 0, 20, 20, 40, 40, 60, 60. We need what? Exactly. We need much more points, and we did it through the grafting. And if we use the graft again, so we go to the we'll go to the sets tree graft. Now it's actually things to come, because this is not how you actually call the nodes, and I already mentioned it before. This is a pretty dumb way of operating with the Grasshopper, but once again, I don't want to go through in this video for all of the shenanigans of speeding up the process. But as you probably already guessed, I'm not using it like this. I'm using a different way to call the nodes. That's why sometimes I'm get confused and trying to remember where things are. So if I'll plug this into the data tree and I already give myself a list, it automatically, using this component inside, find me the longest list and perform a data matching. So I'll plug this into the X, and here is our data tree. Let me actually simplify this. Let me delete this, plug that in here. And you're going to see we have identical result. And we have identical result because list matching was already inside. When I grafted it and put it in X, these values, it forced to replicate Y coordinate, all of these 4 times. And because Z by default is 0, it forces that to replicate for zeros as well for us. And that's how we get ourselves a grid. But we can do another extra step, or basically simplify it even more. You see, graft component, or the data grafting, as well as data simplifying and flattening, is so prominent data management operations that they are built into the nodes also, or not directly, but as a quick access. For example, if I will hover on the start input of a series, right click, oh, look at that, there is a graft command. Flattening, reverse, and a few others, but graft is here. How about the output? Oh, graft again. How about the graft? Graft can be grafted, and the output of the graft can be grafted, and the X component can be grafted, and the output can be grafted. This is a shortcut. So instead of creating the node, I actually gonna plug that directly and say that before it goes to the X component, it's supposed to be grafted. Right click, graft. Okay, so in the end, the actual construction of a grid in the Grasshopper is very, very easy. So as you're gonna see, it's just like 3 nodes technically, well, 4 nodes technically, using because we have two number sliders, right? And this is a very easy operation, but now you know why it is working and what lays behind it in the data management, which is a great foundation for things to come. Now, before we end this video, this part of this lesson, I would like to reiterate a little bit on the panels. Remember, I said that when you bring the value here, you need to type the number and click away. Why? What will happen if you click enter? Well, I click enter and I have a BR tag. So basically now I can type again. Well, let's say 60. Oh, sorry, say 60. And then let's say 2. If I will be clicking enter, I will not be able to, just stop. So I need to click away at some point. But because I clicked enter 2 times, this 20, 60, and 2 is not an integer anymore. This is a string. And indeed, if I will bring, for example, the panel to analyze what's inside, you're going to see that 2062 all sits with all has the index 0. What does this mean? It means that we have tree with a branch name, I'm calling it name last time, a branch name 0 with a leaf, one leaf with index 0, which is 20, 60, 0. This is a string, text data, basically. That's why if I will, for example, try to use it in the start or a step or any other value in a series, it will give me an error. You see it's red now. And if I'll click, it will tell me data conversion failed from text to number. This is not a number anymore. So let me disconnect this. So can we convert it to three numbers then, 2062? The answer is yes. When you are in the panel, if you right click and type multi-line data, it will immediately convert it to the list of data in a very familiar structure. This is the representation of a data tree. So panels are very unique nodes which can actually construct your data trees right on the fly with a lists of data inside instead of a series, for example, right? Well, so I technically can do it manually. You can use formulas as well and other stuff, but that's why if you need multiple data, once again, so long story short, if you want one data, you click away. If you click enter, you will convert it to a string immediately, right? If you don't want that, you click away. If you want to have a list of data, for example, A, B, C, and click away, it will come to be a single string. ABC will be a single string. Multiple strings, multi-line data. What if you want to have numbers this way? No problem. 20, 63. And because it is a multi-line data, it's immediately will become to be a separate data. So that's why I warned you that when you're done, you click away. But this is just the specifics of the Grasshopper. All right, guys, that video was already pretty long, so let me wrap it here. In the next one, we'll proceed with our goal. So I said that we need to construct the grid first for our general goal of the script. But let me say that this one is not suffice for what we really want to do. It's just too basic. It doesn't have enough features and controls. So in the next video, we will go for that and modify that using a different nodes, and on top of that I will teach you a little bit how to bring nodes more effectively and so on and so forth. We will learn new series node, which is important for our task, and basically through these operations we will enhance our grid, make it suitable our needs. And okay, that's it for this one. Thank you very much for watching, and I will see you in the next one.